Imagine you're living a few hundred years ago. Your doctor walks in carrying a jar of leeches, the astronomer swears the stars revolve around you, and your local chemist is boiling lead in hopes of making gold. Sounds absurd, right? Well, that's what people genuinely believed once upon a time. The wildest part is, they weren't stupid. They were doing their best with the knowledge they had. Science, after all, isn't a static rulebook. It's a living, self-correcting mess of ideas, arguments, and aha moments. I'm Mike with List 25, and these are 25 old theories modern science proved wrong. But before we begin, don't forget to like, share, comment, and subscribe with that notification bell. It truly helps the channel. And let us know what other science topics you'd like to see next. 25. Humorism. Ancient doctors believed health depended on balancing 4 bodily fluids called humors: blood, phlegm, yellow bile, and black bile. If you were too emotional, too tired, or just cranky, doctors thought one humor had gone rogue. Remedies included bloodletting, vomiting, or strange diets meant to rebalance the body. It sounds ridiculous now, but for centuries it shaped medicine. When scientists discovered cells, bacteria, and the circulatory system, humorism finally collapsed. Yet, it left behind something useful. The idea that emotions and physical health are connected. That mind-body link, even if it began with a wild misunderstanding, still echoes in modern psychology and holistic care. Humorism wasn't pure nonsense. It was just a blurry first draft of something we'd later write far more clearly. 24. Phrenology. In the 1800s, phrenologists claimed they could read your character by feeling bumps on your skull. Kindness, honesty, or musical skill supposedly lived in specific brain organs, each influencing the skull's shape. People loved it. It felt scientific and flattering. Charts and calipers made it look legitimate, but neuroscience shattered the illusion. Brain imaging proved that thoughts and emotions don't live in neat compartments. Behavior arises from vast neural networks, not little brain bumps. Despite being wrong, phrenology wasn't totally useless. It got people thinking about the brain's structure and its link to personality. It inspired early brain mapping, which eventually blossomed into real neuroscience. So yes, phrenology was fake science, but in a strange way, it accidentally nudged us toward genuine discovery. 23. Bloodletting as cure. If you were sick a few hundred years ago, your doctor's solution was probably simple: lose some blood. From fevers to infections, draining blood was the go-to fix. The idea came from humorism, which I spoke about earlier, and everyone from peasants to presidents got the treatment. Even George Washington was bled heavily during his final illness, which likely hastened his death. Doctors thought the pain or weakness after bloodletting meant toxins were leaving the body. In reality, it often made things worse. Once circulation, germs, and oxygen were understood, bloodletting lost its prestige. Today, it survives only in rare conditions like hemochromatosis. The practice may sound medieval, but it taught a critical lesson. What looks like healing isn't always helping, and science must keep questioning its own confidence. 22. Miasma Theory. Before germs were known, people blamed bad air for disease. The word miasma literally means pollution or foul vapor. In crowded cities, officials thought foul smells spread illnesses like cholera and plague. They burned incense, carried flowers, and built wider streets to let the bad air escape. It almost sounds logical. Disease and stink did go hand in hand, but the reasoning was backwards. In the 1850s, Dr. John Snow traced cholera to a contaminated London water pump, proving infection came from germs, not air. That moment birthed modern epidemiology. Miasma theory was wrong, but its obsession with sanitation actually improved health. Cleaning streets, improving sewage, and fighting odor unknowingly helped stop real pathogens long before people even understood them. 21. Spontaneous generation. For centuries, people believed life could appear from nothing. Maggots from meat, mice from grain, frogs from mud. The logic was simple. Life seemed to just happen. Francesco Redi and Louis Pasteur finally proved otherwise with airtight experiments. Redi showed sealed containers of meat didn't sprout maggots unless flies got in. Pasteur's swan neck flasks kept broth sterile until exposed to microbes. Their work ended the idea of spontaneous life and introduced biogenesis, the principle that life comes only from life. It was a turning point for biology and sanitation alike. Though wrong, spontaneous generation left one lingering spark: the question of how the first life began, which modern science still chases through chemistry and cosmology today. 20. Maternal Imagination. Early doctors once claimed that a pregnant woman's thoughts or emotions could physically alter her unborn child. If she saw something shocking, her baby might bear a mark. If she desired something forbidden, the child might carry a deformity. The belief piled guilt onto mothers for random outcomes they couldn't control. Once genetics and embryology took off, the myth collapsed. A mother's imagination doesn't sculpt her baby, but her health, nutrition, and stress do have real effects on development. Ironically, this wild superstition hinted at a truth science later confirmed. Pregnancy is deeply tied to mental and emotional well-being. Maternal imagination was nonsense, but it carried a seed of empathy modern prenatal care finally learned to nurture. 19. Telegony. This one's truly strange. Telegony suggested that a female's previous partners could influence her future children, even if those partners weren't the father. For example, if a mare once mated with a zebra, her later foals, with normal stallions, might have stripes. It fascinated 19th century biologists and even caught Darwin's curiosity for a time. But once Mendel's experiments revealed how traits are inherited through genes, the theory crumbled. DNA comes from only the two parents who actually create the child. No ghostly echoes from past lovers. The only trace of telegony today is in outdated gossip and superstition, not genetics. It's a perfect example of how science must sometimes untangle itself from the sticky web of cultural imagination. 18. Mercury as medicine. Centuries ago, mercury wasn't a poison, it was a cure-all. Doctors prescribed it for constipation, syphilis, and even melancholy. Patients swallowed it, inhaled it, rubbed it on their skin, or had it injected. The side effects, tremors, hair loss, insanity, were seen as proof of the medicine working. Alchemists loved mercury's silvery beauty, and healers adored its drama. It wasn't until chemistry advanced that we realized it's one of the most toxic elements around. Mercury exposure can destroy nerves, kidneys, and minds. Ironically, its overuse helped scientists develop toxicology, the field that later protected people from such mistakes. Mercury medicine is gone, but its tragic history reminds us that shiny miracles can hide lethal truths beneath their surface. 17. Lobotomy. In the early 20th century, psychiatrists sought dramatic solutions for mental illness. Enter the lobotomy, a surgical procedure that severs connections in the brain's frontal lobes. Patients often become calm, compliant, and emotionless. For a while, this looked like success, and the operation even won a Nobel Prize. But the calmness came at a brutal price. Personality, memory, and intellect were often destroyed. As better drugs and therapies emerged, lobotomy was recognized as a tragedy of misplaced trust. It stands as a chilling example of how science, when desperate for results, can mistake silence for healing. Today, it serves as a permanent warning. Progress without empathy isn't progress at all. 16. The Wandering Womb. Ancient Greek physicians believed a woman's uterus could literally move around inside her body. They thought this wandering womb caused hysteria, anxiety, and fainting spells. Treatments ranged from pleasant scents to lure it back down, to marriage, which was believed to keep it in place. The theory lasted shockingly long, well into the 19th century, fueling sexist stereotypes about women's emotions. Once anatomy and psychology matured, the notion collapsed. Yet, its echo lingers in how women's health complaints were long dismissed as hysteria. The wandering womb might sound absurd, but it left a deep cultural mark, shaping centuries of misunderstanding around women's mental and physical health. 15. Geocentrism. For most of history, people believed Earth sat proudly at the universe's center. The sun, moon, and stars all circled around us. Or so it seemed. It fit human ego perfectly. We were the cosmic focus. Then came Copernicus, Kepler, and Galileo, showing that Earth orbits the sun instead. Galileo's telescope offered proof, but the church wasn't thrilled. He ended up under house arrest for his trouble. The heliocentric model triumphed, revolutionizing astronomy and philosophy. Geocentrism taught a timeless lesson. Science isn't about comfort, it's about truth, even when that truth knocks humanity off its pedestal. The universe doesn't revolve around us. It never did. 14. The Luminiferous Ether. In the 1800s, scientists believed light needed a medium, some invisible substance filling the cosmos called ether. Waves, they reasoned, can't move through nothing. But when Michelson and Morley tried to detect Earth's movement through this ether in 1887, they found absolutely nothing. The experiment's failure was shocking. Then Einstein came along explaining that the light doesn't need a carrier. It travels through the vacuum itself, its speed constant in all frames. The ether vanished overnight. Ironically, its disappearance paved the way for relativity, one of science's greatest revolutions. The idea that space could bend and time could stretch replaced the need for any cosmic fluid. The ether died, but its death birthed a universe stranger than anyone imagined. 13. The Steady State Theory. Before the Big Bang took over the cosmic spotlight, many astronomers believed in the steady state model, a universe with no beginning nor end. It suggested that as galaxies moved apart, new matter constantly popped into existence to keep things evenly spread. No creation, no destruction, just eternal cosmic balance. The idea was elegant, even comforting. But in 1965, scientists stumbled upon faint microwave radiation, the afterglow of a massive explosion that birthed everything. That discovery torpedoed the steady state theory overnight. The Big Bang made far more sense of the evidence. Still, the steady state camp helped shape modern cosmology by forcing scientists to think harder about what kind of universe we actually live in. It wasn't wasted effort. Their challenge made the Big Bang model stronger, more detailed, and more beautifully chaotic than anyone expected. 12. Flat Earth Theory. It sounds laughable today, but the Flat Earth Theory was once a reasonable assumption. After all, to early eyes, the horizon looked straight, not curved. Ancient sailors noticed ships vanished hull first over the horizon, and thinkers like Eratosthenes used shadows to prove the Earth was round centuries before satellites. Yet for some, faith and myth clung to the flat world picture long after reason entered the room. Even in the modern age, some people still push it. Proof that evidence alone doesn't always change minds. It's not just about facts. It's about trust and understanding how knowledge spreads. The enduring flat Earth belief says less about science and more about human nature. Our tendency to hold tight to what feels familiar, even when the truth is staring back at us from space. 11. Caloric theory of heat. In the 18th century, scientists thought heat was a kind of invisible fluid called caloric. When something warmed, caloric was thought to flow into it. When it cooled, caloric leaked out. The idea even seemed to fit how warmth moved through materials. But experiments started poking holes in the story. Count Rumford noticed that endless friction could generate heat while boring cannons, something impossible if caloric was a limited substance. The conclusion hit like, well, a spark. Heat wasn't a fluid at all, but the jostling motion of particles. This realization kicked off the kinetic theory of heat and paved the way for thermodynamics. Caloric theory went up in metaphorical smoke, but not before helping scientists refine how they measured energy transfer. 10. The Immovable Earth. Even after Copernicus placed the sun at the center, people still insisted the Earth didn't move. The logic seemed simple. If Earth spun, wouldn't we feel it? Wouldn't birds be left behind in flight? It took centuries and better math to prove otherwise. Once telescopes revealed stellar parallax, stars shifting position as Earth orbited, the illusion shattered. Newton's law of motion tied it all together beautifully. The idea that Earth stood still finally collapsed under its own weight. Today, satellites measure our planet's spin and orbit precisely, showing we're racing through space at dizzying speeds. The irony? We barely notice. The Immovable Earth theory might seem foolish now, but it marked an essential stage in learning that motion and stillness depend entirely on perspective. 9. The Four Elements Theory. For centuries, people believed everything in the world was made from just 4 ingredients: earth, air, fire, and water. Aristotle popularized it, and it felt intuitively true. You could see the 4 everywhere: solid ground, gases, liquids, and flames. Simple. Beautiful. Wrong. As chemistry developed, scientists such as Boyle and Lavoisier found genuine elements, hydrogen, oxygen, and carbon, that behaved reliably in reactions. The periodic table replaced the lyrical quartet with a precise and testable system. Nonetheless, the ancient elements left their mark. They've endured in philosophy, astrology, and storytelling because they represent balance and change. Science progressed, but the metaphor persisted. The Four Elements Theory exemplifies how individuals seek order and importance, even when the truth is far more difficult than we expected. 8. Early Catastrophism. In the early 1800s, many geologists believed Earth's surface was shaped by sudden, catastrophic events. Massive floods, global quakes, fiery eruptions, wiping everything clean. It made sense when fossils of sea creatures were found high in the mountains. But this worldview left little room for slow, steady change. Then, Charles Lyell came along with a radical idea. The same small forces we see now, erosion, sedimentation, weathering, shaped the planet over immense time spans. Catastrophism fell out of favor, replaced by uniformitarianism. Ironically, modern geology brought the two together again. We now know that both gradual processes and cataclysmic events sculpt Earth's surface. Asteroid impacts, ice ages, and supervolcanoes proved catastrophe has its place in the story. The early catastrophists weren't entirely wrong. They just couldn't see the whole picture. Their obsession with disaster helped uncover Earth's true, dramatic timeline. 7. Alchemy's metal transmutation. Long before chemistry had lab coats or safety goggles, alchemists dreamed of turning base metals like lead into gold. They mixed, burned, and boiled their way through centuries of secret recipes and cryptic symbols, believing in the mystical Philosopher's Stone, a substance that could grant immortality and endless riches. Spoiler, it didn't work. But their obsession laid the groundwork for real chemistry. They developed early forms of distillation, crystallization, and metallurgy. When science finally matured, it shed alchemy's mystical side, but kept its curiosity. Ironically, modern nuclear physics can transmute elements, though at a cost so high, it's not worth the gold. Alchemy failed at its mission, but its spirit of transformation, both literal and intellectual, sparked an age of genuine discovery. Sometimes chasing the impossible leads you straight to the future. 6. Phlogiston Theory. Before oxygen was known, scientists thought fire and rust came from a mysterious element called phlogiston, which supposedly escaped when materials burned. A metal would lose its phlogiston and turn into ash, or calx. The logic seemed tidy, until experiments started revealing something weird. Objects actually gained weight when they burned. Enter Antoine Lavoisier, who realized that burning wasn't loss, but combination. Materials were reacting with oxygen. His discovery demolished phlogiston theory overnight and sparked the birth of modern chemistry. Yet, phlogiston wasn't a total dead end. It trained scientists to measure and experiment carefully, pushing chemistry toward quantitative rigor. It's a perfect reminder that wrong answers can still point in the right direction. Phlogiston went up in metaphorical smoke, but it left behind the tools that made real science burn brighter. 5. Vitalism. For ages, people thought that living beings were animated by a unique vital force that transcended physical rules. They claimed that life could not be explained by chemistry alone. It required something magical. This notion, known as vitalism, persisted until 1828 when Friedrich Wöhler synthesized urea, an organic substance, from inorganic chemicals. The moment was revolutionary. He had built something alive that lacked a vital spark. Vitalism began to collapse. Biology gradually demonstrated that every life process, breathing, digesting, and growth, is based on chemical interactions and energy transmission rather than magic. Still, the idea lingers whenever people talk about life energy or essence. Ironically, vitalism's failure made science more alive than ever, inspiring generations to uncover the actual mechanisms behind life's mysteries. Sometimes disproving the magic is what makes the real wonder shine brighter. 4. Indivisible atoms. The very word atom means indivisible, and for centuries scientists believed atoms were the smallest, most fundamental pieces of matter. Democritus imagined them as tiny solid particles. Later, chemists agreed. Then came subatomic surprises. Electrons, protons, and neutrons shattered that simplicity. Eventually, quantum mechanics revealed an even stranger truth. These particles aren't solid at all, but energy fields dancing in probability. The indivisible atom turned out to be a buzzing universe of its own. Ironically, the early atomic model wasn't a mistake so much as a stepping stone. It let chemists build the periodic table and predict reactions before quantum physics complicated the picture. Every generation thinks it's found the final layer of truth, until the next one digs deeper. 3. Lamarckism. Jean-Baptiste Lamarck had an elegant idea. Creatures could pass on traits they developed during their lives. If a blacksmith had strong arms, his kids might be born stronger. If a giraffe stretched its neck to reach the leaves, its offspring would start with a head start. It made intuitive sense, but nature doesn't always work on logic alone. Darwin's theory of natural selection, combined later with Mendel's genetics, showed that traits arise from random variation, not effort. Evolution isn't a conscious grind. It's a long, messy filter of what works best. Yet Lamarck wasn't entirely off. Today's science of epigenetics shows that environmental pressures can influence which genes turn on or off. So while Lamarck got the mechanism wrong, he grasped something profound. Life is never static. It constantly responds, adapts, and adjusts to the world around it. 2. Preformationism. Imagine scientists once believing that every human began as a fully formed microscopic version of themselves, a tiny pre-built person curled up inside a sperm or egg. That was preformationism. In the 17th and 18th centuries, biologists debated whether these little beings lived in the male or female reproductive cells, calling them homunculi. The logic felt tidy. No need to explain how something complex could grow from a single cell if it already existed in miniature. But when microscopes improved and embryology took off, the illusion shattered. We discovered development wasn't unfolding a hidden doll, it was building one from scratch, cell by cell. Preformationism faded into scientific folklore, but it revealed a truth about curiosity. Humans will imagine anything to fill the gaps of the unknown. Sometimes the wildest guesses are just placeholders for real discovery. 1. Cold fusion craze. Martin Fleischmann and Stanley Pons, two chemists, stated in 1989 that they had accomplished nuclear fusion at room temperature, a clean, infinite energy source with the potential to revolutionize everything. The world went crazy. Labs raced to recreate it, investors poured in money, and newspapers declared it a revolution. Then, reality crashed the party. No one could reproduce their results. The energy readings turned out to be measuring errors, not miracles. The enthusiasm gave way to one of the most well-known science disappointments of all time. However, cold fusion was not wholly worthless. It sparked further study into alternate fusion processes, such as low-energy nuclear reactions, which continue to get discrete financing. The hope of low-cost, safe fusion continues in large-scale programs such as ITER. Cold fusion showed that hope can ignite faster than proof, but it also reminded us that real breakthroughs take patience, precision, and brutal honesty. And that's it for today. But if you want to learn more about groundbreaking scientific theories, check out this video here. I know you will love it. As always, thank you guys so much. Like, share, comment, subscribe, do all that fun stuff. Notification bell, hit that too. Again, thank you guys so much, and I'll catch you next time.